Hello, STEM Nation. Jeff here, and welcome to episode number 61 of STEM on Fire, where we interview practicing professionals in the area of science, technology, engineering, and math to help guide students interested in STEM careers. If you like what you hear, please share it with a friend. Now let's get fired up today with our guest, Brad, and I hope our chat will help ignite your passion towards a STEM career. Brad earned a Bachelor of Science in Mechanical Engineering from the Milwaukee School of Engineering and a Master's in Agricultural and Natural Resources and a Master's in Water Resources Engineering from UC Davis, and is currently a Senior Water Resource Engineer in Santa Clara, California. Welcome to the show, Brad. Fill in any gaps and share a bit of your personal life.
Thanks for having me on the podcast. In 2010, I did graduate from Milwaukee School of Engineering, as you stated. I then moved out to California immediately for grad school at UC Davis. Got married in 2011, where my wife and Emily and I both found work out here after school in the Sacramento and San Francisco Bay areas. I've had a fortunate mix of academic, consulting, government experience, others as an engineer, which I look forward to discussing here on the podcast.
All right. Great, Brad, for that great overview. And let's dig right in here. So looking at your LinkedIn profile, I noticed that you've got a Bachelor of Science in Mechanical Engineering. And then I'll say you kind of pivoted more into environmental and ag and water resources. To me, they seem kind of disjoint. So can you go into a little depth on why you made that transition from mechanical into more of the civil environmental realm?
Sure. Well, coming out of high school, I knew that I wanted to get into engineering. And I initially looked at mechanical engineering because of the kind of broad options that the major has in manufacturing, automotive, hydraulics. And as I started to move into the later years into my technical electives and other sorts of courses that I could take outside the sort of core classes, I really had a personal interest in the environmental resources, took a number of courses that were environmental focused at Milwaukee School of Engineering, and then tied that together with my hydraulics background that I had obtained through the mechanical engineering courses. So as I was looking at graduate school to move out and expand my knowledge and get a little bit more focused in an area, I was kind of entertaining ideas of where that might take me. And I had an opportunity at UC Davis to come out here and develop a sensor system in agricultural water resources and irrigation management. And at first, even though it didn't seem to have much of a connection with mechanical, the more I sat back and said, well, I'd be developing a full sensor system. There would, of course, be the components there, the manufacturing of these sensors, and then there'd be pulling it together into an environmental, more hydrology than hydraulics, but still water and kind of a fluid dynamics, if you will, type setup. So I initially got into that field and got slowly amazed by water management in the Western U.S., specifically California. So that was through research out here in the Davis-Sacramento area. I learned more about water resources and water management and the way that in California waters just moved across the entire state. So it was really taking it that step further and getting that sort of genuine interest in the history and the engineering of what's been done out here in water resources, and then moving towards civil, because that was sort of the next step on moving towards the larger scale planning and management of water resources. And so I like to tell people, when you step back at the 30,000 foot level of how I've gotten here, the mechanical engineering side is really played into sort of understanding water conveyance, the pumping systems, the canals, the hydraulics of how water's moved around the state of California. The ag engineering really helps to understand where a majority of the demand in the state goes. A lot of people may not be aware that California is one of the highest producing agricultural states in the country. And then, of course, the water resources, which was a subset of civil engineering that I can get into in the podcast here. But that really tied it all together in the larger scale sort of planning and management of it. So the short takeaway is that it doesn't always have to be a straightforward path through similar types of degrees like civil all the way through. You can kind of allow some of the subsets of these majors to kind of play out and see how they piece together. And that's how I got on my path here towards a very interesting career.
Okay, Brad. So, with your undergrad in mechanical, and then going into civil. In my mind, I always thought that, hey, if you're going to go for a master's in civil engineering, you probably need a Bachelor of Science in civil engineering. So did you have to go back and take courses that you missed from your undergrad in order to get your master's, or is it kind of completely separate?
In my case of moving on from mechanical engineering into civil engineering, I didn't actually have to take a number of the sort of prerequisite courses that weren't really involved in my topic of water resources engineering. I think in a lot of ways, master's degrees sort of take on an undergrad in a certain subset or focus topic. In my case, it was agricultural engineering and later water resources in the other masters. And so I really focused on those courses, and having the mechanical engineering degree that touched on a lot of fluid mechanics and others, I really didn't have to go back to those core courses, if you will, and really didn't have to touch on any of the geotechnical or structural or transportation that typically comes with a civil engineering degree. Again, I think once I got to that point, it was easy to focus more on the water resources, large-scale planning, water management classes that were of particular interest to the research projects I was looking at the time.
All right, thanks for that, Brad. And so why did you head down the ag and water resource path?
As I was moving on to mechanical engineering and looking for opportunities to find a specific path on which I was trying to go down, a specific sort of subset of mechanical engineering that I wanted to study, I was looking at different options for graduate school and different options to sort of expand and build out into a specific focus. And what came up from a personal interest in environmental resources, spending time outdoors, and matching that with the hydraulics and other sort of fluid dynamics classes that I spent a lot of time at as a mechanical engineer in technical electives and others, that was where I came across the opportunity at UC Davis to develop this sensor system and get into the project that I mentioned earlier, which just happened to be a sort of application in agricultural engineering. It wasn't that I necessarily went out looking for an agricultural engineering type project. It was more that I was looking for opportunities, happened to get in contact with someone at UC Davis, and they sort of presented this opportunity to me. And as we sat down and described exactly what it was going to entail to build a sensor system or pull together the modeling and analysis of looking at irrigation management and trying to preserve water resources and increase conservation in these type of irrigation systems, it just seemed like a really interesting application of the things I had learned to date and the personal interest I had in sort of the environmental management.
All right. So, Brad, you touched on this a little bit, I believe, where, being in the civil engineering world and maybe working with the water and the resource and the canals, are you in the office all day long, or do you get out in the field? What does a day look like for you?
Let me pick here for a sec. Sure. Most of my time is spent in an office reviewing data, looking at different documentation and analysis of these large water resource management systems that I talked about there. Let me rephrase that. Most of my time is spent in an office reviewing data, documentation, and analysis of these water resource management systems that I touched on earlier. I have a lot of frequent meetings with state and federal regulators, different project proponents, making decisions on these large-scale infrastructure proposals, such as reservoirs, or even working with transfers and exchanges of water supply. So it's a lot of office work and then analyzing data and looking at different supply management kind of on the fly.
Okay.
I also do. I'm sorry. I can expand on that.
No, go ahead. No, go ahead.
Yeah.
Yep.
I also have a preparation of a lot of white papers, engineering documents, covering analysis and making recommendations for other imported water projects, ways of getting water to the district. This is all under the review of different technical risks, and I can provide analyses to executive staff and elected board members that we have for the water district. So from an engineering standpoint, this really involves a significant portion of water demand data and assessment of annual supplies and demands. When I was with the Department of Water Resources, for instance, I would often meet with outside water-related stakeholders for new statewide programs. We have a number of them out here that plan for 5-year updates, taking into account droughts and flood situations and others. So really working with different stakeholders under this large sort of planning and management rubric for water resources.
All right, Brad. And we're going to move here to something that really has you fired up, an area of could be mechanical, ag, water resources, or anything in general.
Sure. Well, let me touch on water resources. That's because that's where I am now. And in the Western United States, it's been really interesting to be a part of this larger effort and this large historic effort because a lot of folks are coming to terms with the environmental impacts of these large water diversions and reservoir systems from the 20th century engineering. A lot of it was built in the early to mid 1900s when the environmental concerns weren't really the care as much as water supply for agriculture in the cities. And so now the analysis of environmental and ecosystems impacts, which weren't certain at that time, are really kind of coming to full circle right now, and a lot of planning is going into trying to reoperate our water systems and do different analysis of environmental and long-term impacts. So I'm fired up because water managers like myself and others really face many challenges in California. It's an interesting opportunity to be impactful on a very critical resource in water. An example of California, for instance, is California is literally sinking in elevation in parts due to the extreme groundwater extraction that we've seen in the past. So trying to reconcile that and try and limit these broader impacts. And then if I can step more broadly, there's been an encouraging trend in engineering of data management. Web and resources tools have really enabled engineers and others to collect a lot of data related to resource management, in my case, and the environment. Data science tools that are out there, such as programming, Python, and others, have allowed us to better manage and analyze these large sets of data with great accuracy. So I would encourage aspiring STEM students to become really comfortable with programming and coding, especially for data science and management purposes, because that's been very important as well.
I'm going to go back here a little bit. Did you say that California is actually sinking?
Yeah, there's something called groundwater subsidence in parts of the southern Central Valley where the elevation has dropped many feet over the last century. Yeah, there's a famous picture down in the southern San Joaquin Valley by Bakersfield area, more or less, that shows a guy pointing up to the top of a telephone pole, and that was the ground elevation in the early 1900s.
Wow. We'll have to add a link to that in the show notes, so check that out. I'm going to go check that out after this podcast.
Yeah, and just to expand on that, sorry for interrupting, but just to expand on that, it's been really interesting to see how that's had an impact on these large water delivery and canal systems moving throughout the state, where when the ground is sinking due to these extreme groundwater extractions, it's actually limiting the capacity of these canals to move water south, which is a critical component for Los Angeles and others. So it's a very complex problem.
All right, Brad, and thanks. And we're going to move on here to an aha moment. Brad, could you take us to a moment in time where you've had an incredible aha moment and how you turn that moment into success?
Sure. During my graduate studies at UC Davis, I started to understand the bigger picture of research and coursework. It's easy to get caught up in individual courses and specific topics. For agricultural engineering, for example, I was researching irrigation management, and I started to understand it as a part of this sort of larger water resources demands, as I kind of indicated earlier, that it was really understanding that ag water use in California is around 4 times that of all the urban areas in California combined in a single year. So really understanding the bigger picture of just how much water irrigation uses. And that really started me on my path to GEI consultants and really getting interested and amazed by this sort of water planning and management system we have out here in this state. I'm not sure a lot of others are aware of the amount of federal funding or state funding in California that's gone towards moving water in this state. And so my advice more generally is that you may not always be involved in a sort of bigger picture, especially early in a career. It's hard to really feel like you're part of that bigger sort of project or bigger sort of overarching theme of what's going on in your discipline or whatever you're working in. But consider the long-term outlook and don't lose sight of that. Ask questions and learn from project managers, supervisors, and others that have been in the field for a long time. Know that you're eventually going to get there. It's going to take some time, but really feel as though you're part of something, and whether you know it or not, you're likely an important cog in that sort of big wheel of moving forward on an important topic.
Brad, I'm going to ask a question coming from an electrical engineer is, you're out in California and you've got a vast ocean right next to you that
Sure.
is just like an unlimited amount of water supply. Is it the fact that just a desalination to get the salt out is so expensive, or is the technology not there to support that?
It's a little bit of both, to be honest. Of course, my expertise is not in desalination, so I can only speak to the larger planning efforts and some that I touched on when I was with the California Department of Water Resources. It's not to say that there aren't efforts for desalination out here, but as you indicated, they are very expensive typically, and really resource intensive, energy intensive in particular. There's just the efficiency isn't quite there yet to do it on such large scales, and to really understand the amount of water that California, in particular the urban areas like San Francisco and LA, use in a year. The current desal efforts just aren't there to really meet or take a large chunk out of those demands.
Sounds like a challenge. If you're interested in the water resources, it sounds like if you could crack and figure out how to do desalination low cost and very efficiently, might be a path to solving the water issues in California. So think about that.
Certainly would agree with that statement.
All right, Brad, and let's go back to Milwaukee School of Engineering, MSOE, and UC Davis, and getting through college. It can be challenging. So if you could go back to when you're 18, what are some things that you wish you knew back then heading off to college?
Don't get scared off by math and science requirements. I wish I could have noted that to my 18-year-old self, that math and science will get easier and more interesting when it's applied. When you get into calculus and physics, from the outside, it may seem challenging, but as you kind of see where that fits into particular design problems or others, it really can kind of click and make more sense as you're moving through your courses. And then for college course catalogs, which many of them are online for various degree programs, take time to look into school lists and descriptions online, these different course catalogs. Review when you're applying and starting. The warning is that you won't understand all the content now, the descriptions of the classes that you'd be expected to take, and you don't need to. That's the point of moving through a degree. But get a feel for what kind of courses you may be taking. If you sign up for a mechanical engineering program at one school, you may be more automotive focused than another school, which may be more hydraulics and other types of manufacturing skills. The nice part about Milwaukee School of Engineering was that it was broad enough to where I could take a number of technical electives that I was interested in, and they had these sort of different subsets where I could take one from hydraulics side, take one from manufacturing side, and that's where I really started to hone in towards the end, which gave me the confidence to step into that agricultural engineering research program I mentioned earlier. And then early on, looking for different internships and research opportunities, it certainly helps with finding that focus. Internships help the job hunt later on when it has that experience on your resume to go forward. And research will also help with grad school later if desired. Research experience, specifically in a lab or others, can be really important for graduate school. And even freshmen can find that work. Show an interest or willingness to learn and grow your resume. That can really help out even early on in school. And so the last piece I want to add on to that is, as an 18-year-old self, kind of maybe pre-college, as you're considering where to go, think about where you hope to live and work long term. A lot of times this isn't mentioned, but the school will really kind of set you up for where you want to live and perhaps what type of area and focus and different type of topic you want to be part of. MSOE, Milwaukee School of Engineering, for instance, was great, strong Midwest reputation, but relatively unknown out West. And so I understand that going to school in California, if that's where you want to end up, could be hard with in and out of state tuition costs and various other reasons. And it's not impossible. Clearly, I was able to make it out here, but just remember that local companies will attend the career fairs, events, and have job opportunities, most likely for the schools that are closest to them, because it's easy to travel there and try and recruit others and whatnot.
All right, Brad, thanks for those great insights. And STEM Nation, listen to what Brad is saying. He provided a lot of guidance there, a lot of insights. And if you want to reach out to Brad, I'll have his LinkedIn link on the show notes. So you can click on that and connect with Brad and say, hey, I heard you on the podcast and I have a couple questions for you. I'm sure Brad would be willing to help guide you. And Brad, it's lightning round time. Are you ready?
I'm absolutely ready.
What's the best piece of advice you've ever received?
Don't be afraid to speak up when you have something to contribute, regardless of the audience. And that can be executives, professors, etc. You will learn by participating, so don't get caught up in details. Learn to summarize your work, bring it down, and kind of make it easy to digest for people you're talking to. But if you're in a group that has some people that are on that executive higher level, if you want to contribute, be forward and just go for it.
And a personal habit that contributes to your success.
I'm consistently looking for opportunities to expand my skill set or increase my knowledge. I've been amazed at the availability of online resources. LinkedIn, for instance, that you mentioned. You can look up what successful people have done in your field. Look at their degrees, their credentials, what conferences are they attending, networking events, and others. Even simple Google searches can be really useful. You can learn keywords and phrases. It can help with finding information or even having conversations at these sort of networking events and others.
And a favorite internet resource or phone app, and why?
Coursera and edX are both online course systems that are free from major universities. I've taken multiple courses off there on those websites, and they offer STEM ones such as resources management, programming and data science, and fundamental engineering topics. They're not usually all that intensive. They're free, and I believe high schoolers and other early college folk can sign up, not that they need additional coursework load. But certainly for some of the basics and programming and data science, they can be really helpful.
And one book you would recommend?
Cadillac Desert by Mark Reisner. As I was getting more interested in water resources management in California, this book really is essential reading. It talks about the amazing engineering developments in the 20th century. These pipelines, canal systems, these reservoir systems that really had no limit at the time. As fast as Congress could appropriate new funds for these large projects, they were getting built. I want to say there's around 1,200 or so dams in California alone.
Cadillac Desert. And Brad, as we wrap up here, can you share a parting piece of guidance for STEM Nation, and then we will say goodbye?
Be proactive. Always look for chances to grow and build yourself as a STEM major, and that can be through courses, extracurricular activities, networking events. I called and applied to multiple grad programs before I ended up at UC Davis. Obviously, as I mentioned here, I was searching out and kind of looking where I could take my mechanical engineering degree and really moving into a different type of work or something that would kind of spoke more to my interest in environmental resources. And so I had called, I'd looked into, and Davis worked out really great for me. I was able to get a fellowship to come out to California. Just be proactive and look for different chances and opportunities.
Brad, and with that, we will say goodbye.
All right. Thanks again, Jeff.
You're welcome, Brad. I hope you enjoyed our chat today with Brad. Head over to STEMonfire.com, subscribe to the email list to keep up with the latest happenings, and be sure to subscribe to the podcast on your favorite podcast player. And please share with a friend. Tune in next week where we talk with Nikita, who is an applications engineer. Until next time, I hope this chat has helped ignite your passion towards a STEM career.